Once again, welcome to my YouTube channel, Maths with Ease by Mr. Kamotho. And in this video, we want to go deeper into probability and try to understand some complicated cases using example 4. And we are being told that Onyabiri is an albino koala in San Diego Zoo. Albinos are born without melanin in their skin, which results in them having a very pale complexion and white fur in the case of koalas. That is just a narration, but now the mathematical aspect begin from here. The probability of a koala having an albino gene is 1 out of 75. The albino gene must come from both parents. We have to underline the probability. At the same time, we have to underline must come from both parents. The albino gene must come from both parents, but then only 1 out of 4 cubs, baby koalas, produced by a pair of albino gene carriers is an albino. And I want to explain that. An albino cannot be born by a koala who is not an albino. That is number 1. So we have to have the gene, the parents have to have the gene to give birth to another albino baby. And if even as such, both parents have to be albino carriers. They have to be the gene carriers. The albino gene must come from both parents. So it's not a case of where one parent is having the genes and the other parent is not having the gene. We cannot have an albino from such kind of a combination. So for us to have an albino, both parents must be carriers. And as such, we would want now to talk about even when both parents are carriers, then only one albino out of 4, 1 out of 4 cubs, baby albinos produced by a pair of albino gene carriers is an albino. Now we have a case now here. First of all, what is the probability that a randomly picked albino will be a carrier? Find the probability of 2 randomly paired koalas producing an albino cub like Onyabiri. First of all, we have to have a carrier and a non-carrier. Any albino, any koala which is picked at random is either going to be a carrier or not a carrier. C prime is not a carrier. The probability of any koala having being an albino carrier is 1 out of 75. The probability of not being a carrier is the rest, because this is 74 out of 75. We understand that the total has to be 1. This non-carrier does not produce, this carrier cannot produce. I don't think this carrier is going to produce an albino, but let's see. This non-carrier we can pick another. If this was the mother, then we can pick a father who is a carrier, or we can pick a father who is still a non-carrier. And again, we have, if we picked a mother who is a carrier, it is also possible to pick a father who is a carrier and a father who is a non-carrier. And as such, we can now see that this non-carrier mother combined with a carrier father, we cannot have albino. We cannot have albino. So albino here is 0. An albino here is 0. And an albino there is 1. An albino here is 0. The probability of producing an albino is 1. Of course, both of them who are not carriers, the probability of producing an albino is 0. The probability of picking an albino is 1. Or giving birth to an albino is 1. Both parents, carrier and a carrier, here we have a probability of having an albino, and even then it is 1 out of 4. Whereas we have a probability of giving birth to non-albino, which is 3 out of 4. We have to be very careful here. A carrier and an uncarrier, it is impossible to produce an albino, and we can only produce an albino there. Now, what is the probability of picking a carrier? 1 out of 75. Non-carrier, 74 out of 75. A carrier, 1 out of 75. Non-carrier, 74 out of 75. Now, the question is, find the probability of 2 randomly picked koalas producing an albino cub, like Onyabiri. First of all, we have to have a mother who is a carrier, and the probability is we can only have this root. This is the only root, and that root is being summarized by a carrier, and a carrier might produce an albino. This root is a carrier. This root is a carrier, and even another carrier, there's a probability of not producing an albino. This root is a carrier and an uncarrier and producing albino, which is 0. And this root is a carrier and an uncarrier producing an albino. And all the others will be like that. So, in short, this is the only root that will give us an albino, or it's likely to give us an albino. So, we have to have a carrier and an albino. So, what is this carrier? The probability of a carrier is 1 out of 75, followed combining with a carrier further, 1 out of 75, and they produce an albino at the rate of 1 out of 4. So what is this probability in short? This is 1 out of, let's see, 75 times 75, 75 times 75 times 4. It is 22500. It is 22500. And that is the probability of 2 carriers producing an albino. And that is just the answer, because all the others will not give us any albino. Thank you, and let us meet in the next video.